Hi, hello everybody. So this is section 4 dealing with linear functions and slope. So I'm going to show you here exactly what we need to do in this section because this section is primarily used for section 5. Okay, so let's take a look uh, at the work I have over here. Now, there are different forms of the equation of a line. So here you can see the standard form of the line looks like this. And here's an example where A, B, and C are just any numbers, usually integers, to make things easier for students, but they could be any number. So for example, 2x plus 3y equals 6 is a linear function. The reason it's a linear function is the variable x and the variable y has only an exponent of 1. Okay? Now, normally we don't like this equation of the line. So we are going to always use this one over here. This is called the slope-intercept form, and we're going to see more of it in section 5. Now, when the equation is in this form, and I am going to show you how to go from the standard form to the slope-intercept form. When the equation is in this form, the m represents the slope of the line, and we're going to discuss it shortly. This is the inclination of the line with respect to the x-axis, and this value b represents the y-intercept, where the graph crosses the y-axis. So the main thing that we need to be able to do is rewrite this standard form equation, if it is given to us in this form, into the slope-intercept form. So I'm going to do here on the side. It's very easy. We're going to see more of it, but let me just do it here for you. So the goal is to isolate the y variable on the left side, which means in this case I have to minus 2x on both sides to start off. So the positive and the negative 2x cancel. I'm left with 3y equals negative 2x plus 6. And now, in order to make this equation into the slope-intercept form, I cannot have any number multiplying the y. So I have to divide everything by 3. When I do these, both 3's cancel. I have y equals negative 2/3 x, 6 divided by 3, positive 2. So this is the equation of the line that we are interested in working with, not the standard form as you see over here, but the slope-intercept form that we see over here. The reason for that is now this number here, the negative 2/3, represents the slope, and this value represents the y-intercept. And the equation of the line in this format is very useful for us because it allows us to graph the line very, very easily. And I'm going to show you today toward the end of this video. Okay, so let's take a look at the next topic over here. So the first one is being able to convert the line from standard form to slope-intercept form. Next, it is going to be very common, especially in the next section, that we are going to be given 2 points, point 1 and point 2, right? So remember, a point has coordinates x, y. And when we are given those 2 points, we may need to find the slope of a line that passes through those 2 points, as you see over here. In order to do that, and we call that obviously slope, as I mentioned before. In order to do that, we are going to use this little formula over here. Okay, so if point 1 is x1, y1, and point 2 is x2, y2, the coordinates of the point, then the slope formula says that we have to divide y2 minus y1 by x2 minus x1. Okay, provided, of course, the two x coordinates are not the same. So whatever number we get from here, this is going to be the slope of our line passing through those 2 points. Now it's important, and I'm gonna show you a couple of examples, but it's important to first realize the different possibilities that we may get with slope. The one that you see over here, in this case, it is a positive slope. Okay, so let me just pull this a little bit more so you can see in the video. So if the line is increasing to the right, it's a positive slope. If it is decreasing to the right, it's a negative slope. If the line is parallel to the x-axis, the slope is 0. And if the line is parallel to the y-axis, the slope is undefined. Normally, these two last cases don't happen very often. And on the exams, you should really focus primarily on the first two. These two may also happen on the final, but it's unlikely. We're more interested in you knowing how to find the slope. The slope is positive or when the slope is negative. Okay, so in order to find the slope when we're giving 2 points, we're going to use this formula, and I'm going to show it to you now. And these are the 4 possible types of slope that we can get: positive, negative, 0, and undefined. All right, so I'm going to do 2 problems. I don't want to do 4 because they're very, very similar. I think if I can do 2, you should be able to understand how this thing is done. Okay, so let me just backtrack a little bit here. Okay, so let's see. All right, so this is fine now. So this is a typical question. It can happen in this section, but it definitely will happen in the next section as well. So we want to find the slope of the line passing through these points. Okay, so I'm going to call this point 1, and I'm going to call this point 2. Then the first coordinate is x1, second is y1, x2, y2. So now we have to remember the formula. And you remember the formula from before, right? I'm going to write it here again: y2 minus y1, x2 minus x1. Now be very careful, right? y2 is the -3 minus, this is the minus from the formula, y1, which is 2. x2, which is 8, minus x1, which happens to be -2. So be very careful, parentheses -2, okay? This is the minus from the formula, this is the minus from the point. So numerator -3 minus 2 minus 5, and this is 8 plus 2, right? Minus times a minus is a plus, 8 plus 2, 10. And then if you have something like this, you can simplify the fraction by 5, and we get this. So here's the slope of a line passing through these 2 points. Is a negative slope, so the line is going to be decreasing to the right. All right, that's all we have to do to find slope. Second case, same thing. I'm going to call this P1 and P2, which means that this is x1, y1, x2, y2. Again, we use the formula, y2 minus y1, x2 minus x1, y2 is 5, y1 is 3, x2 is -4 minus x1 minus 1. All right, so be very careful with these double minuses. So 5 minus 3, 2. -4 minus -1 is -4 plus 1, which is -3. Now, don't ever leave a minus on the denominator. You can write it as -2/3. So this is the slope of the line, which also happens to be negative. Okay, so it's very simple. You can call either point 1 or point 2, but you're going to apply the same formula, which is y2 minus y1 divided by x2 minus x1. And be very careful with the minus. This is the minus from the formula. This may be a minus from the point. Okay, so this is how to find slope. So again, sometimes, especially in the next section, we are going to be given a problem that looks like this right here. We are going to be given an equation and it's in standard form, which is not very useful for us. And our goal is to put this in slope intercept form. This is always going to be our goal. Okay, so the textbook or our workbook works it for us. So we need to isolate the variable y. So we do minus 5x on both sides. These two cancel. And then we need to have a single y on the left side. So we divide everything by 2 here, as you can see. These two will cancel. Minus and minus becomes a plus. 5 over 2x. 8 divided by negative 2 is minus 4. So this is the equation of the line that we want in slope-intercept form. Okay? When the equation is in this format, this value right here that multiplies the x, 5 over 2, is my slope. And this value here, minus 4, is my y-intercept. Now, when the equation is in this format, we can use it to graph it, and I'm going to show you how to do it in a couple of minutes. Okay, so we already seen this before when we have an equation in standard form, how to convert it to slope-intercept form. So this was just a review from the very beginning of the video. And now I am going to show you how to graph an equation given in standard form. If the equation is already given to us in slope-intercept form, it's even easier, but we're going to go from here. Okay, so graph this equation. So the very first thing that we're going to do is put it in slope-intercept form. Okay, so let's see, 2x plus 3y equals 15. So you remember slope-intercept form is this, which means I have to isolate y on the left. So minus 2x on both sides. And I cannot have more than one y on the left, so I'm going to divide everything by 3. These two will cancel. Negative 2/3 x plus 15 divided by 3, 5. This is the equation that we want. The slope, you can write it here on the side if you want. The slope is negative 2/3. And the y-intercept is 0, 5. Or just 5 if you want. Okay, now how do we graph this? So this is step 1. We put it in slope-intercept forms. 2, we are going to plot the y-intercept, which in this case is 0, 5. The y-intercept is always going to be 0 and some other number. In this case, it's 5. So, and it's on the y-axis, right? So this is the y-axis, this is the x-axis. So 0, 5 is right here. Right? So that's step 1. Plot the y-intercept. 3, we're going to do what we call, and the details are on the workbook itself, and here I'm only summarizing. We're going to do rise over run from the y-intercept. Okay, rise over run is my slope, which in this case is negative 2 over 3. Now this is what you're going to do. Rise over run. You're going to look and you're going to start at the y-intercept, which is this location here, 5. If the numerator is negative, you're going to go down from the y-intercept. If it is positive, you're going to go up, however many units you have. In this case, it's 2. If I had positive 2 over 3, from the y-intercept, I would go up 2 units to 7. Because it's negative, I'm going to go down 2 units from 5. And then you're going to take a look at the denominator. The denominator is always going to be positive, and you're going to go this many units to the right. So from here, I'm going to go 1, 2, 3 units. Okay, so here are my 2 points. All you have to do now, fourth step, is trace a line through these points. And you're done. So I'm going to try to do my best to do a straight line. And this is the equation of this line right here. That's all you have to do. 3 steps or 4 steps. First, put the equation in slope-intercept form if it's already not in slope-intercept form. Find the slope y-intercept. 2, plot the y-intercept. 3, do rise over run. And then 4, trace a line through those 2 points. Okay, and then you have the equation of the line. I'm going to do one more problem for you to see. Make sure that you understand this. But it's basically the same thing. All right, so let's try this one again. The equation is in standard form. So step 1, I'm going to put it in slope-intercept form. And you can do it along with me if you want to see if you understood. So remember the equation that we want is y equals mx plus b. So minus 3x on both sides. And in this case, now I have a minus 1 here. There's an invisible 1, so I'm going to divide everything by -1. So I will get y. These two minuses cancel. The minus and minus cancel. 3 divided by 1 is just 3x minus 7. Okay? Now, it helps if you don't have a denominator, just leave it over 1 so you don't get confused when you have to graph. Now we identified the slope as 3 over 1. And the y-intercept is -7. Okay, so that's the first step. Second step is plot the y-intercept, which is 0, -7. So here is, and remember, it's on the y-axis. So here is my y-intercept at -7. 3, I am going to do rise over run from the y-intercept. Now, so here's my slope. We use the slope for that. Numerator is positive, so I'm going to go up from the y-intercept 3 units. So from the -7, I end up at -4. And then the run is always to the right. I go 1 unit. So here is my point, 2 points. All I have to do now is trace a line through these points. And let me see if I can do this. This is very hard to do it here. All right, so this is the best I can do it on this environment. And this is the equation of this line, which gave us a slope of 3 over 1 and a y-intercept of -7. Okay, so this section, we have to know how to do pretty much everything that I've covered here. And this is the only thing we have to know. And this is going to be useful and used in the next section, section 5.